I want to welcome you to today's webinar, Nursing Homes Clean Central Biomass Heat, presented by Mark Froling, who's the president of Froling Energy. But first, I wanted to alert you to our next webinar, which is Forest Sustainability from a Forester's Point of View. And what this is about is the reaction to various ideas about biomass. One, that it's a terrible thing. We shouldn't be burning a single tree just because of the fact that it's spewing carbon just like oil does. And another one says that we should just let our forests grow unused, untouched, and that would abate all the carbon possible so that we could avert catastrophe. And we have respect for those opinions and would like to come up with the best possible idea for sustaining our forests and for combating climate change. And we wanted to get other points of view, and that would specifically be, in this case, foresters who have years, decades of experience in the woods and have seen different things happen, have seen different approaches to forest management, including just letting it grow. And there's some good information there. I thought it would be a good idea to have this kind of a conversation. So it's going to be a panel discussion. It's April 1st at 3 p.m. and we welcome people to log in. You can sign up through our event site, Eventbrite site, and you can find that just by going to Eventbrite or to our website, frolingenergy.com. You can also link to it through Facebook and so forth. There's different angles here. Every one of our webinars, if you happen to miss one, is recorded and it is posted on YouTube. And we welcome you to go there at any time, 24/7, without any restrictions, to view these videos. And there's going to be some 14 of them here very shortly. There's a dozen there right now. So today's webinar is Nursing Homes Clean Central Biomass Heat. It's a review of a big project we did in Westmoreland, New Hampshire, which is a project called the Maplewood Nursing Home, owned by the Cheshire County. And it is a big renovation that we took part of back in 2018 and 2019. First, I'm going to tell you a bit about Froling Energy. We are a mechanical contractor. We work only in the most high-tech, most clean and efficient biomass boiler systems that are available. And we install them in school campuses, schools, our biggest project area. We've renovated many school boiler rooms and installed biomass systems. Dry wood chip and wood pellet systems is what we focus on. Commercial buildings, industrial buildings. Our biggest account is an industrial account that burns many tons, that offsets over 200,000 gallons of oil a year. We're pretty proud of that. Multifamily buildings are another good central heated area, and residential homes, individual homes, we do some of as well. We are a self-performing contractor, so if you have a project that is a boiler room renovation, but there's not enough room in the boiler room, we can help build a boiler building, outbuilding from the main structure. We can assist with project management, with all the subcontractors required for that project, and right on down the line to system commissioning and making sure everything is running properly. The technical consulting side is a big part of what we do, and that means that if someone has an idea for a project, if they have an existing building, they'd like to understand what the possibilities are, we're certainly very happy to assist. So we recommend that you give us a call, and we can help you with everything from the specifications to grant applications if we know pretty much what's available and what can be applied for. And we also manufacture PDCs, which we call precision dry wood chips. It is a bullwood chip. It is dried to 25% moisture content. They're screened and chipped so that they're no bigger than about a matchbook size. And we can then deliver them by blower truck because of that lightness and that size. So they get blown through a 6-inch pipe, a hose initially, and then up into a silo and can rise up some 30 feet up in the air. So it's a real game changer when it comes to storage, a low-cost storage system. And you can see that these are steel silos. So when it gets down to -10 outside, are these going to freeze solid? No, they don't. 25% moisture prevents that. We have had higher moisture content and it freezes solid. So not a good thing when that happens. So it's an interesting product, a niche product that's kind of in the middle range for big schools and industrial situations and so forth. Smaller buildings actually have made use of them. It's a good thing. So today, again, nursing homes with clean central biomass heat, presented by Mark Froling, who's the president of Froling Energy. And Mark has been doing construction and construction management for many years, started in San Francisco, and he came to the Southwest New Hampshire about 25 years ago. Mark has many roles on the Froling Energy team, such as system design, materials procurement, project management, system commissioning, troubleshooting, as well as leading the company and all of that entails. The company has been working on biomass boiler systems for 12 years, and that was all from Mark's inspiration. In doing this, our company has obtained a lot of knowledge and helped to evolve the design of parts of these systems that have now become standards in this industry in New England. Mark has been involved in all of this. So please welcome our speaker today, Mark Froling.
Today, I just wanted to really talk in specifically about this one project that we completed actually just now only. In fact, there's still a couple labels missing here and there. So the project is still under construction, but our scope is mostly finished. And the building that we're showing here, this is probably close to a half a year before we even got into the heavy work of things. So this is just when we are looking at the feasibility of it all. And so we were approached by the mechanical engineer of the holistic project, because our portion of this whole project is quite minor in comparison. So this overall was close to, I think it was about a $40 million project overall to upgrade this nursing home from what you see here to what you see here. Let's see here. Yeah, to what you see here. And I'm just on the back side of the entire building, so you're not getting a full upgrade. This is not what you'll see as we go along. You'll see a lot more of the thing. But so our scope, of course, we did the hydronic system within the building, within the new parts of the building and the old parts of the building on the remodel side. So it's a pretty large addition got added to the existing nursing home facility. And then the main building that was already in existence there has been completely remodeled. So it was complete gut job on the existing building. And of course, the new addition was sited to the south side of the building, or the southwest side of the building, and is now in the front. And you'll see that soon. And to provide the heat, the owner had, after some feasibility, had selected the biomass as the baseload boiler, and then the backup boiler was designed as an LP boiler. And so it's a condensing system, even though most of the time when this boiler is in action, it's really in non-condensing conditions. But there are some summertime moments when it's just on DHW where the boiler can be fully condensing and producing heat for the DHW system. So I'll start in the very beginning. As you saw here, the picture first, without any alterations. In order to get to this next picture, there's a whole bunch of steps that had to get tried out in between. And we started with a really basic sort of drafting exercise, design exercise in the feasibility. Initially, there was an intent to provide more biomass, more sort of firepower on the front end, or maybe a whole biomass, without any backup boiler. And then towards the end, it got actually selected with just a single silo and a single biomass boiler and 2 backup boilers. So, but this is what you typically see from us, sort of a feasibility that shows our trucks coming and going, that shows a boiler plant or variations of several boiler plants. So in this case, we had 2 boilers and 2 silos. In one, we had 1 boiler with 2 silos and also 1 boiler with a live floor storage here. That was just sort of the conventional design that the designer initially had come up with. And then we went through drafting and seeing if the equipment actually fit into this building and how that would impact the traffic around that. And it's complicated grade too, because it's a little bit on the hillside there. And there's very valuable parking in the back. So a lot of considerations. There's also power lines and other utilities that had to be considered as well. Plus, most importantly, the phasing, which is really complicated because the existing system was actually an old steam system. So here we came up, with sort of a schematic design so we can actually put some pricing to that. And through these kind of exercises on the front end, we then can hone in a little bit more on what the ultimate design would be. And then, once we ended up getting into a contract, which actually was a reduced scope of what we had initially proposed, just to basically a value engineered proposition with single biomass boiler and 2 LP boilers and an indirect hot water system. So then we could, after the contract, we could get into the more specific designs about the buffer tanks and how the stairs lay out and how the equipment lays out and how we can get the equipment in for delivery. Is, as you go along, you realize how tight everything had to be, especially because of the phasing. And as we get in it, not to mention there's considerations for NHDES. The air permit is a really complicated permit. We always use outside engineers to consult us on that along the way, and it's really complicated to navigate your way through there. And even though we have done it several times now, we still use outside consulting engineers to proceed with that. And so you have to do all these studies. Here's a little study showing our interconnection to the existing ALF wing, which was a wing that was actually not remodeled, but had to be considered for the tie-in because it had to be kept warm at all times. And so it was also a critical part of sort of where we had to pipe through to first in order to keep everything warm going through the first winter. Because there had to be a transition point where we had to take old boilers out, leave one running, put new boilers in, get those up and running, and remove more boilers. And all of that had to be really carefully considered. Of course, all the plans were sort of done on a pretty intricate model, which in most cases works pretty well, but it's also, you have to be on site because existing conditions really trump everything. You can model all you want, but ultimately, existing conditions never turn out to be exactly how you think it would be. And so you go through this planning feasibility and then the planning process, and then you can actually start at the very beginning, at the same old picture here, nothing gets done. And then you start slowly building away and getting the first demolition done. We're looking at the old existing boiler here and the 2 new Wiesmann boilers right behind it installed. Oops. Here's some more demolition out of the heat exchange. I'm not even sure where that is. Maybe in the ALF actually. The old condensate system. All of those things had to be left in place for a certain amount of time and then removed at the exact time in order to cut over. While all of this fairly complicated phasing exercise was going on, we also had to get the major distribution pipes in order to pick up the existing buildings. As we talked before, the phasing was so critical. So our home runs or the main runs of the piping had to be put in quite quickly in order to not lose that first heating season, because that was very critical to keep people warm in the existing wings. And so all of this, the renovations, or not the renovations, but the new construction on the additions was going on while the two, on either side, the main building and the old ALF wing, was still fully occupied. And so people had to construct in between. It's a very, very complicated phasing exercise. And so you can see normal operations, people are working in the left side of the building here, and the new construction or the addition is going in front of you here. And this is what it looked like where we're getting our very first Wiesmann boiler. It's a package boiler, comes fully assembled, and then it just gets pushed into place. And that boiler right next to it is still operating at this point. And then within a few days, we start mechanically interconnecting and tying into the old system so we can keep indirect systems working, to keep heat exchangers working. We really didn't have a lot of downtime to make, to gut the whole building and start fresh. So everything, we were working around demolished goods at all times, and putting new stuff next to the demolished goods. Here's a little bit of what we had to do in order to keep systems in. This is the new construction main piping going in, 6-inch piping and 5-inch piping going to the various parts of the buildings of the new addition. A little pressure test. And here's the very first day of our silo that is going in. And so the silo work itself is actually embedded into the concrete. And so there's a starter ring that gets poured in, cast in place, and then the concrete locks it in. And that dictates everything. If that is not round, guaranteed your silo will not be round. So puts a little bit of pressure on you when you're pouring all this concrete to get it exactly right. But it turned out very good. And then before you know it, the silo walls go up and the silo roof go on with a nice crane. And it does look like we're very close to the power lines, but there's a little room, so not to worry. And there's the completed silo with a fill tube and the staircase as well. And there's a little bit more to the staircase because there's always a little bit of unwanted guests onto staircases. And so we actually designed and custom built this gate or enclosure to keep people off it. And here are the two guys that mainly put this system in. And this is actually now we're getting into the boiler system installation here. And so we've been working away at the piping on the distribution. We've been putting backup boilers in, the LP boilers, and the backup, there's LP tanks have been put in the ground, and lines and high pressure and low pressure lines are in there. And now we're receiving the boiler. In order to get the boiler in, the entire front wall of that bay had to be removed because the boiler is about 14 feet tall and we only had a 15-foot ceiling or so. So it's very, very close dimensions. All of that had to be modeled in the beginning in order to really get the system in. Here's the piping in place. So once the boiler gets in, it can then be connected. You can see the building is moving along quite nicely as well at this time. And here we are on the very first day of the lift, unloading the trucks and getting all the parts and pieces in. And here you can see both sections of the boiler, the lower section on the ground and the top section on the crane right now. All of that is by our crews. We are a self-performing crew or contractor. We do the piping, we have a piping crew, we have a rigging crew, and we also have controls people in-house, and I perform the design and the modeling and more of the project management support. And it's a little bit, even though we have a crane, it's more or less an Egyptian operation here in the way that we have literally roller bars on the ground, and we kind of repaired the concrete floor that had deteriorated over time so we could roll this new boiler into place. And here the top end of the boiler gets lifted on and placed on carefully with the right fittings and gaskets. And there it is in place. And once it's in place, the tiny little bobcat actually pushes it in on these just on steel bar. And it just barely fits in by 1 inch or 2 inches. It fit into the door. And here you can see one of our guys, we could only use 3/4 inch bars to get it in. That's how tight the tolerances were. And then slowly but surely it's moving inside the building, and I think it's still moving forward a few more feet here before it's in the final resting place. You can see a little bit, this is the buffer tank I showed earlier in the presentation. The buffer tank is really important part of the design. For most part, during operations, the buffer tank is not used, but during shutdown and during startup, the buffer tank provides a good amount of energy to either absorb during shutdown the energy that is not needed in the distribution system, and during startup, it provides a buffer time until the boiler is actually under power. If you don't have these buffer tanks and there is a huge drop or a quick drop, a sudden drop in the distribution system, the boiler might still have a tremendous amount of wood inside the combustion chamber, and all that energy needs to be stored somewhere. You can't just overheat the boiler. And so the buffer tank provides that kind of, well, literally the buffering demand or buffering solution. It's a little bit like a battery where during the swing moments, you either store or deplete that battery for the need of the distribution system. The phasing in this project was so complicated. It was a 2-year project overall, and with all the different phases going on, we had to tie different systems in at different times. So it's complex to stage materials, different contractors, and different timings in order to tie in the different systems. So we actually had a lot of additional work just to phase through that. The boiler, what we were looking at right now is actually the recirc fan, and that's really important for a dry chip boiler. If you have dry chips, they're quite a bit have quite a bit more energy than the green chips per pound, and but they're very dry, and so the boiler can quite easily overheat if you don't have a recirc. Flue gas recirculation. The flue gas is of course oxygen depleted, and so it's a method of actually cooling the combustion chamber by mixing the depleted flue gas with the fresh air, and thereby in fact cooling the combustion process down and not letting it run away and over temp. That a lot of boilers actually cannot work with dry chips because actually cooling the combustion area is a pretty complicated operation. Also, we are cooling the grate of this unit as well. So the burn grate is protected by 190-degree hot water or 180-degree hot water. I know that doesn't seem like it's cooling it, but compared to the 600 degrees C combustion temperature, 200-degree hot water is extremely cool. So that is part of the process as well. It is oftentimes you have to really design, if you have an operation that has a tremendous amount of resources for facility operations and service maintenance, you can make things a little bit more manual, but in this case the facilities is of course quite stretched thin, and so it was here that we choose to make a design where the ash was actually, rather than being manually raked out on a daily basis, it is actually augered out of the boiler and into an ash container. And then on a weekly basis, the ash container can be emptied. It collects the fly ash from the cyclone that protects the exhaust gases, but it also collects the great ash from the front. That's that incline conveyor coming up. So from the front of the boiler, there's a little cross conveyor that collects all the ashes in the front of the grate. Then it transports them up on the incline conveyor. And then the vertical conveyor is it's a fall shaft from a horizontal conveyor underneath the flue gas cleaner. On the other side of the boiler room, you have on the bottom picture the DHW system. It's an indirect coil system. And then the backup boilers are, as mentioned, I should just say Wiesmann condensing gas boilers, LP boilers. A few things. I have now talked a little bit of why we chose this boiler, and there's many reasons. I mean, of course, price was a big determining factor, but when we went through the feasibility, it became very clear that the room and the access and unloading was all very critical because of the existing parking site and the sloped hills. So unloading had to be done, in a way that it can't have too steep of a grade, so we don't have to build all this site. So we didn't have to do all these improvements on the site work. And also the vertical storage really appealed to the owner because it took up very little footprint, and we didn't have to rearrange a tremendous amount of utilities to put this one silo in. And we did not have to take parking spots because of this. So there was an appeal from, there was a preference to this technology in a way that it could use the dry chip vertical storage in the exterior bin, and then have a tractor trailer or a straight frame truck come and fill that up with basically a tailgate operation. It's a pneumatic fill cycle, which of course takes time, and it is a little bit noisy, so that's a nuisance, but it's been working quite well. Other considerations, as I mentioned, the automatic ash removal and the fully automatic conveyance. On the bottom of the silo, there's a spinning blade, and it stirs the chips over the auger that you see there, the orange auger in the middle of the screen. It's an incline auger that comes from the center of the silo to the stoker screw. The stoker basically then stokes the fuel, the biomass fuel, into the boiler. And so this compact design and still good power output here was very appealing to the owner. It's a little bit of a picture of the buffer tank during the beginning, coordinating things with the sprinkler guy. We were in a really tight environment everywhere. And then of course we had plumbers and sprinklers and electricians to coordinate with as well. And it was all done by plan and then through coordination meetings on a weekly basis. And this is during light up, when we are actually, this is maybe a day into the curing of the refractory, and we took a little picture of what the fire really looks like during this kind of operation. And here's the completed boiler with the controls, with the boiler controls next to it. The boiler controls then ties into the BMS and provides the information to the owner. It's a fully automatic system all around, and the cut over to the backup boiler is also automatic. So this is just a little picture showing the boiler screen on the right hand side, and then the PDC system, or the building management system on the left-hand side. It's just showing the boiler pumps, or the distribution pumps, in fact. So this is a picture of, us during work. We set up our shop there. There was a way to be very close to the boiler room. This is an enormous site. You can easily lose track of all your workmen and the help and the management. And so we were able to actually sort of set aside a little bit of area right next to the boiler room. And that was extremely beneficial to get this operation really tightly managed. And this is a picture of a filling still during the commissioning period. I think that might have been one of the very first fills. This is the last slide, I believe. Yeah. So I want to talk a little bit more. This is actually a slide of our operation in Keene, New Hampshire, where we actually bake the chips and provide the chips and then truck them over to Maplewood Nursing Home. And it's probably about a 15 or 20 mile ride or so. And of course, this is a very local client for us to bring the chips over there. But even so, we're now in our second year. We're still getting used to sort of the load curves of the building. In the beginning, not a lot of distribution or heat was in fact installed. So the load was quite small in the beginning, and then we had trouble with, in fact, keeping the boiler on and having a lot of ignition cycles in the beginning and all kinds of troubles, because it was really during construction. And then as construction was more and more finished, we had a really good load to make that boiler really work, and that boiler wants to work. But then other things come in, and you sometimes during construction, you have power outages and all kinds of things that can go on. And we certainly had all of these pretty normal troubles during the construction period, and that it's sort of a little bit normal for us to see that all, but it's actually been up until now, so we can really see and correlate the outside temperatures with their load curve. And so it's a pretty large user. The addition is quite large, so we did not necessarily have we estimated based on the new square footage and the new ventilation that was being put on, but the boiler seems to be operating quite well. I think when it gets very, very cold, or if there's very sudden load demands for weather reasons or other reasons, the backup boilers do come on. It was to be expected. It was not this backup boiler was really designed for about 90% of the annual fuel use, and we can ask Bruce if it's actually achieving that. I don't know if we had enough runtime at this point yet, but so at 90% annual usage, the design load is really 75% of the peak. And so that's how this was designed, and I believe that we're achieving that load. For the most part, it heats the building just fine, but sometimes we have some demands where there's a very rapid rise. Maybe it's a high heat demand and a high domestic demand, and those periods can the domestic can actually be quite a large demand at any one point in time there. So if something is being really changed dramatically, the backup boilers do come on, and that seems to be working quite well. I think that is in fact it for me. I'd love to take some questions if anybody has some questions.
Right, and we can take those by the chat, the written chat, as well as if you'd like to open up your microphone, you can just speak that. Wait your turn, and I'm sure we'll coordinate this. First question here from Pat. It says, how will the economics of the Maplewood project be impacted if New Hampshire stops offering thermal RECs?
Well, the thermal RECs are, of course, very nice. And basically, The fuel bill for an institution like Maplewood is about $130 per ton right now. And so the REC provides about 50% of that as a rebate directly to the fuel. And so let's say your bill is right now $100,000 a year, and I'm just making this up because I don't actually know what the Maplewood Nursing Home is using on an annual basis. But you know, if it's right now $100,000 and you don't get the REC in the future, in fact, it would be $200,000. But so it would go up by, you know, 50%, or I guess it would go up by 100%, come to think of it, because it's a 50% drop savings. But it would still be well below oil. Oil right now is going up quite a bit right now. And so the old fuel and propane has gone up quite a bit as well. So we would still be well below fuel oil or propane. Typically on most days or years, we are 50% discount over fuel oil or propane, or even more. So the savings are quite large regardless, but not as large as it is with the REC. The REC is tremendous. It's a tremendous helper for us.
Right. If I calculate this out, I think they're probably going to be using somewhere around 1,800, 2,000 tons, just as rough record of what we've seen so far. And so that times, we'll call it 1,800 times $16. That's about a $29,000 income if it was a net of about $16, because there's whatever, that's about what we figure most people will come up with. So so they'd lose that. And obviously that's a piece of this, you know, that we should say on the payback, you're just looking to reduce your costs. But the difference is compared to what? Compared to oil, compared to LP. In this case, they'd be stuck with LP. I'm not sure what are you paying now for LP? I wonder, Bruce, if you can answer that.
Yeah, it's $1.28.
All right. Yeah. And obviously these are prices that we may not continue to have. You never know about the price of LP or the price of oil.
Right.
Now, Pat continues on the questioning about the thermal RECs, and it's true that New Hampshire was threatening to get rid of thermal RECs, with one particular legislator, you know, suggesting this legislation. It went to the Energy Committee, the variety, whatever, the committee that handles that. And
Bill 213.
Right. And it was amended, and they were going to say, oh, we'll grandfather everybody that's already got thermal RECs. You know, that would be wonderful for those people. But on the other hand, it's a wonderful stimulus to get people to do these kind of conversions. And it's quite fair, I think, all the way around. I think the way it functions. We're going to, you know, everybody needs to fight that to make sure that the thermal RECs stay in place. And right now it looks like we have another year of thermal RECs before they can approach this again. So we'll see what happens. And
yeah, that has been going on for a few years, that every year there's some contingencies that threaten to remove the RECs or to devalue the RECs. And but there's also equal sort of push on the other side to in fact increase the RECs as well, because there's House Bill 113, or no, 103, I think right now, that is on the docket in the House as well as in the Senate, and that is promoting the idea to double the RECs. So in that case, they would increase, and that would be beneficial, of course, to us, of course, as well as all of our users of these chips or any of the biomass boilers, because we have now over 250 biomass boilers out there in the countryside, and anybody that's using RECs would be a beneficiary of that if the RECs in fact went to a higher value, because they're trying to raise the ACP, which dictates more or less the REC value.
The topic here today is about nursing homes in particular, you could say, but we really are just one nursing home, and there are many situations that would be similar to this. There's many nursing homes with very modern equipment, but the idea is that it's a large scale system. And I think Mark showed that pretty well, that the big pipes, big complexity. There's a lot to consider, and it's not an easy kind of a project to put through. I wonder, part of the steam to forced hot water conversion was a big part of this, Mark. Can you just tell us a little bit more about that?
Yeah, it's a complicated conversion because you have two different mediums. If it was all water, then just reconnecting to the water side would have been easier. But we in fact had to really, the timing was pretty difficult to achieve. Of course, it was all done, but it just provides a much more complex system because you couldn't just leave piping in place. We had to, because there was some steam runs to other heat exchangers, and so these steam runs had to be removed, and all of that while we're also trying to do sort of distribution construction and repiping entire buildings. Several, this I think close to 100,000 square feet that we had to completely repipe. In terms of distribution. So it's a really complex undertaking, and it just needs to be phased out correctly. It needs quite a bit of experience how to phase that out. I think we had a really good team here, and it was challenging for sure. Everybody was scratching their head during the parts of this, but I think the team made it possible to get through that, and one by one, phase around and attack different areas of the existing or the new additions, and get them online as they became available or as the construction in those areas finished. But it's because of the different medium, steam versus hot water, it was more complicated.
What would you say are the advantages of getting out of steam and going to hot water?
It's really simplicity. And steam per se is not at all bad. I have nothing against steam. In fact, in some cases you really need it, but there's more maintenance on steam versus a hot water, just because you have to treat the system all the time. And so the corrosive behavior of, say, the condensate side of the whole piping system is really severe. So you have a lot more sort of decay in your pipe system. There's a lot more maintenance on traps versus if you're just having control valves in a building. Control valves are fairly maintenance free, and there's good amount of energy savings and that's a big advantage, because there's a lot of blow by on these traps, because of course, this is a pretty old system. In many cases, this is 40, 50-year-old distribution piping that just had a lot of unmaintained traps, because in many cases, you didn't even know where they were. They were completely hidden and not being able to be maintained. And so I think the new owner will, on the distribution side, it is much, much simpler. Of course, having the DDC versus I believe most of the building really was still on pneumatic control. So having the DDC now with a push of a button, of an electronic button to control certain areas, is very nice, or even automated, of course. But so I think there's a little bit more versatility, a little ease of maintenance. Certainly, there's a lot less chemical treatment. The way it's set up. Generally, I think the hot water provides a good amount. We typically, what we see going from steam to hot water, we always see a 10% savings right off the bat. And then there's some control savings on top of it. So I wouldn't be surprised that under normal conditions, the heat load should have gone down. Of course, this was an enormous addition to this building. So I don't think the load went down, because the new addition is thousands of square feet being added. And then also because of rules and regulations, we have to increase ventilation by quite a bit. And then having a COVID year on top of it, I think we probably hit the trifecta in this particular installation, where you have probably a little bit more usage than we thought. So it's not so easy to predict all these things, but I think the design in general is a really robust design, and certainly was able to save from the first capital or from the very first design to this design. There was a lot of a capital expense shed, and so the savings brought to by this performance contract there through EEI was a pretty good win for the owner to reduce the cost, the overall cost of the job. And then now they have a good savings in the operational cost. And this boiler is a really robust boiler, you know, the most robust boiler that you can buy from us right now. It's stout and it's really automated. And I believe that the owner, I'd love to, after a couple of years, to hear from Bruce what his opinion really is on that. You know, it's still pretty early to tell, but it would be nice to hear, to see if his actual maintenance really has gone down. You know, certainly having all new equipment, and, you know, you would think that the maintenance will go down a little bit. There's parts of steam that is also quite valuable. For instance, you don't have pumps like that. So you're not having any pumps to maintain is something nice, but the overall steam system is always more complex in piping and always more complex in maintenance. And then the chemical management is much more, there's much more oversight on that now. And so in order to keep up with warranties and whatnot, I think the hot water system, or hot water with glycol, is just a much simpler installation overall.
Okay. With the DDC-based control system, I should think Bruce has a control panel where you can see the whole building.
Yeah.
That's not what we do, but that's got to be one of the features of the new heating system.
Oh yeah, yeah.
And we did install all the heat distribution system, as I recall. Am I right?
We installed the hydronic heat distribution. So we just did the water side, and then the final or terminal distribution is mostly done through air terminals, through VAB boxes and fan coils, unit heaters, and things like that. So wherever we are, we typically terminate it in coils, and then the HVAC team came in and in fact did sort of the air movement.
Mm-hmm.
So it's done in conjunction. So we did not do all the final distribution. We did sort of the heat distribution in terms of running all the piping to the coils and terminating at the coils and doing all the control valving in for those coils.
With Bruce said that his cost on LP, I believe he said it's $1.28 a gallon on LP that he's buying currently for those big boilers and whatever purposes on site there. Yeah. With thermal RECs, that ends up, the PDCs, the dry wood chips, end up costing about 60 cents a gallon. So more than half the price of a very low price on LP.
Yeah.
So I think that's still a good testimony to the value of PDCs. On schools and hospitals, those are very often termed as sensitive receptor areas. In other words, we're worried about people taking in smoke that might come out of a boiler system. I think a lot of people generalize and they say these wood boilers are very smoky and dirty. Tell us about, what's your reaction to that? This is a very sensitive receptor area. Any hospital would be. So tell us about this boiler and just how it handles that and the testing and so forth.
Yeah, right. So, so sensitive receptor, that goes back to the particulate emissions mostly. And this boiler, the Schmid UTSR boiler, when we tested it and then run calculations also on the PM 2.5 and things like that, because we were trying to calculate for other job sites or potential job sites to see how good this boiler really, or how clean this boiler really ran, and it did exceedingly good. And so in our neighborhood, in the sort of the 4-state area here, between Vermont, New Hampshire, Massachusetts, and Maine, Massachusetts has the highest or the most restrictive guidelines in terms of emissions, and it's especially particulate emissions. And so this boiler, after we tested it, we compared it to the Massachusetts guidelines, and we were well within the guidelines of the Mass, I believe it's called DEP in Mass. And so we're certainly well under the New Hampshire DES guidelines, always qualify with every single boiler we've always put in, but we're also always putting in really high-end boilers. So these are not sort of the low-end boilers without any kind of back-end control. This is a really careful combustion design. It's sort of a distinctly 3-zone design where they manage the combustion airs in real distinct zones. They really control the combustion, the sort of the fire, the grate itself, and keep the fire very stable, and are through this design of the grate and the firebox, they're able to basically limit the particulate emissions rising up into the airstream. And then, of course, we still have the airstream protected with the cyclone, which is, I think, maybe a 10-pack or a 12-pack of cyclones on the rear end before it goes into the flue gas stream. And so between those two, between the combustion control designs and between the emissions controls, we've just been doing extremely well with meeting all the requirements in the different states where we've been tested. And we've always been well below even the most stringent tests. So I'm quite, I'm feeling very secure about what we're putting in. And having said that, we always sort of choose the best available technology. So we try not to go to the lowest end of things. So I do also expect the best results from the best available technology. So I think that goes without saying. And we do have to test these boilers, and it's a very expensive test, so failing would not be good. So we're all dealing with a $10,000 test on these items. And so this has proven time and time again that we can pass them with flying colors.
All right. I'll suggest that if you want to learn more about this particular boiler type, the Schmid boiler, there is a webinar about that in particular. So you'll learn a lot about their current technology and some of the future things they're working out. Like the latest version, I guess, is going to be coming with a video camera that we'll be able to visualize the flame in real time. They do that now, I think, in some of their tests, but among other things. But it's a company that spends a lot of time on the R&D side and tries to make the best possible boiler. And that's why we import these. They're Swiss manufactured boilers. Well, are there any other questions? I've got this up for chat here. If anybody wants to put that anything in, if there is something, if you'd like to just verbalize, you can unmute yourself and try that. I will point out again next week, I really want you to attend this and tell people that might have interest in this, the forest sustainability from a forester's point of view. And that's a show, I think, with a panel discussion, a little different than what we've done in the past. We'll have 4 different panelists, and we'll be asking them questions and getting their input on what we should be doing in our forests in New England and what we're doing currently, and ideas that are being floated around, some reactions to that. Any other questions? And I want to thank Mark for spending his time today. He's got lots going on, and he took a number of hours to set up his presentation and then to give it today. So thank you, Mark. And anybody that wants to watch this or pass this on to a compatriot, we will have a recording available very soon. So watch for that online. And I thank you very much. Thanks for attending.